One difference in the nature of hero development versus non-hero development is the level of understanding of the problem world and data. In non-hero development, one can relatively easily write and build a set of requirements, with much of the difficulty arising from the process and the human side of things. A good example of this is a chat application such as WhatsApp or Telegram. Programming for a chat app deals with the static set of requirements. For example, being able to add contacts, send private messages, or being able to send media like images or video. Hero development includes this process along with one additional challenge. The world and data may be unknown, invisible, and always changing. In our messaging app example, consider a model that must classify certain messages as spam, or complete a sentence, or tag a message as important versus promotional. This state of uncertainty and change makes it hard to build a set of requirements because we may not know what to require until we actually perform some modeling. Sometimes we may be able to write requirements since the objective of the experiment is to make and validate hypotheses about the space. We see this often in simulation problems. Even here, there's a hypothesis validation exercise that precedes the build. There can be no build if the hypothesis is invalid. Hero problems may sometimes have a large variety of inputs known as features or dimensions in math jargon. Human beings can visualize up to 3 dimensions in a plot. As we add more dimensions, the shapes get more and more complex. For hero problems that are more than 3D, we will never know what the shapes look like because we can't visualize them. This means that learning the data can only be done by modeling it. In reinforcement learning, there's a technical notion of exploration versus exploitation, which applies largely to life in a deeper sense, but specifically to the process of hero development. Let's start here. How do you build a set of requirements when you may not know what's required? The answer lies in exploration. Exploration is akin to experimentation. Without this initial part, where are we learning about the problem? It makes no sense to build anything. Exploration is about discovering what works, learning a world, and building experience. Exploration is about small POCs, the use of experimental languages like Python or R, and iteration. Through the process of exploration, we continually tweak and revalidate our hypotheses. So once you've defined your world through exploration, then what? This brings us to exploitation. Exploitation is about applying learning and experience to make things work. In practical application, exploitation involves using standard project methodologies, writing requirements, and building code optimized toward an objective. Given that learning is cyclical in nature, we go back and forth between ideas and test many things before we can tell what works. Learning isn't linear, but the most common project methodology, the waterfall, is. Design for hero methods is synonymous with exploration. In this course, we focus on exploration. In the examples we use, the hierarchical and pipeline steps are suggestions for experiments. Most likely, when experiments fail, the solution is typically to test other methods. If methods don't work, we change the approach. So for example, if scaling doesn't work, try customization. If customization doesn't work, try building a model with the full dataset. If that doesn't work, change your hierarchy level. Kato AI.